Question 8, we tackled the wild slungs known as trig functions. So we've been given a whole bunch of information here, and this doesn't look nice to my brain, so I'm going to color code this thing and it'll look a lot better. And check what a difference that makes. Okay, so first up we need to get the values of m and n. They are sitting snug inside the equations over here. So let's start with the cos x and get the m. So I'm going to analyze the cos x and I'm going to see how it's transformed from the original graph. In order to do that, you need to know what the original graph looks like. This is a must know. You must know this off by heart. So cos x has like a wavy shape, and we always use this point as our reference point. Cos x should start on 0 and 1. So cos x should start there, but now it's starting there. And this m over here is responsible for moving the graph up and down. So if you think about it, we just moved it down half a unit. So this m is minus a half. We must say minus because it moved down. If it moves up, we add it. Alright, now let's tackle the sine graph. Okay, so let's think of the original sine graph. So the original sine graph also has like a wavy shape, and then this is our focal point. It should start at 0 and 0, but this one doesn't start at 0 and 0. It starts at minus 30. So this graph has been moved 30 to the left. And if we look at the equation of that graph, this variable over here, if you're adding something to the angle, if it's inside the brackets, that moves the graph left or right. So we establish that this graph moved left 30 units, so it's got to be plus 30 over here. So if you're moving left, it's plus, and if you're moving right, it's minus. So all of this was like a sneaky little ploy to help you get the equations of the graphs, because they're not just asking for m and n, they're kind of asking you like complete the equations so that you have the proper equations for these graphs. And now that that's out the way, we can actually start answering questions. Now we have to write down the amplitude of f, which is our blue graph. So the amplitude is normally the number in front of x, and if you have a negative number there, you take the positive version of it. To give an example of that, if I had this cos graph, the amplitude would just be this number in front of cos, and you do not take the minus. So after that quick little sidetrack, the number in front of cos x is just a 1, so the amplitude of f is just 1. I'll even do you one better, I'll give you the amplitude of g. It's the number in front of sine, it's 1. The next question asks me to write down the amplitude of h. If they say write down, it means that there's no working out that needs to be shown, you simply just write down the answer. I'm going to do a bit of working out to explain how you do it, and then we'll just list the answer at the end. Okay, so h of x is a completely new function, and it's g of 2 of x. Okay, so let's go get that equation, let's have a look at it and see what to do. So h of x equals g of 2x simply gives you instructions to grab g and just replace your x's with 2x's. So that's exactly what I've done. I've taken g and I've changed x to 2x. And now to get the period of something, you've got to remember the periods of the original graphs we were having a look at earlier. Really easy to remember, sine and cos, the original graph's period is 360, and then tan's period is 180. So those are stock standard. You've got to know those off by heart. So I'm going to take the original period and then divide it by the number in front of x to get my new period. So my original period is 360, divide that by the number in front of x, and we get the new period of this h of x to be 180. And of course, if they say write down, they kind of want you to do this all in your head and just give them that answer over there. I find I cope better with actually working it out like this. So I kind of ignore this advice. I'll still get the mark for my final answer here. So let's have a look quickly where all the marks are coming from here. They purely just going to be coming from the answers. So yeah, each answer just earns you 1 mark over here. But very hard fought marks. You need to know quite a lot of knowledge to actually get these marks. 8.4, we've got our challenge round. For which values of x will f of x times g of x be less than or equal to 0 in the interval from 0 to 240? So I'm only doing 0 to 240, so I'm going to ignore this side of the graph. So let's kind of get rid of it for now. So we're only going to be doing 0 to 240. Okay, now if I analyze this, f of x represents a y value. So to translate this in English, f of x is the y value of this blue graph. G of x is the y value of the green graph. And I want to multiply those together to give me a negative number, something smaller than 0. Or it could give me 0, something equal to 0. So there's only 2 possible cases where that can happen. And those 2 possible cases is if I say a positive times a negative or a negative times a positive. That will give me a negative number. So I start all the way on the left of where I'm analyzing. And I ask myself, what are the y values here? The y value for the green graph is positive at 0.5. And the y value for the blue graph is positive at 0.5. And as I move along the graphs, things change over here. Now all of a sudden the blue graph has a negative y value and the green graph has a positive y value. So it's working after 60. So I'm going to start formulating that over here. So this is kind of saying it starts happening at 60, and I'll put a square bracket because we have an equals to inequality over there. Okay, then it keeps working, but over here things change. Now all of a sudden the green graph has a negative y value, and the blue graph also has a negative y value. So it stops working over there. So this ends at 150. And then I'm going to quickly analyze if it ever happens again. It looks like both their y values are negative from that point onwards. So it won't ever work again. That's the only region where this is actually working. And you simply just get your 2 marks for writing that down. Bear in mind you can write it in a different notation like this. That is also acceptable. I found most people sort of understand this route, so I prefer to use that with these inequalities, but this is perfectly fine as well. And now the last question asks, to describe the transformations, which implies there's more than one, that the graph of G undergoes to transform to the graph of P, which has this equation. So I'm going to take more of an algebraic route here. You can use a graphical route as well. So what I want to do is change this to be x plus 90 so that I can use my co-ratios or co-functions. And to accomplish that, I'm going to need to add 60 to this angle to transform it into sine of x plus 90. And in terms of transformation, that means I translated the graph 60 degrees to the left. Remember, it's the opposite signs for left and right. Left is plus and right is minus. Okay, so now I've got a co-ratio. I've got sine of 90 plus theta. You can just change the order of this. It won't affect anything. 3 plus 4 is 7. 4 plus 3 is 7. So the order of addition does not matter. Now we're almost at the finish line. We just need to change this cos x to minus cos x. So if I times this by a negative, that implies that I did a reflection over the x-axis because y will turn into negative y. It's quite complicated to see that, But if you see a sign change happening with everything in your equation, you can just remember that you're reflecting over the x-axis because y became negative y. So that's going to be our second reflection here, or our second transformation, reflection over the x-axis. And then lastly, the 2 marks will come from describing each transformation. So yeah, literally you have to write the words to describe the transformation. And that wraps up this paper.